Well, with the lesson that we just learned here for when the magnetic field is constant over a straight wire, it should be a fairly straightforward matter to actually get the force here on side C, right? Once again, we have a wire that's parallel. It's maintaining a constant distance from the source of my field. So the magnetic field will be constant over this wire. So my same rule will apply. So let's just take care of that then. That was side C, that upper side. And the answer then is going to be just the current flowing through my wire, I2, times the magnetic field, B, at the location of my wire, times the length of the wire, which actually happens to be L. And now, according to my rule, I better do a cross product to get my direction. So I look at the flow of the current, the direction it's flowing in, and I cross that with the magnetic field. In this case, the current is flowing to the right, and the magnetic field is down into the page. So if I were to do that cross product, I need my fingers on my right hand pointing off to the right, and then I rotate my wrist until it's easy to curl my fingers down into the page towards the magnetic field. And when I do that, you'll see you end up with your right hand with your fingers to the right and your palm pointing downward. So then when you stick out your thumb, you pick out the direction of the cross product, which is going to be up the page in this case. So F from C is going to be pointing upward. So it's the exact opposite direction from the wire below. This also makes sense because now notice I've got two parallel wires, but for these wires the currents are now in opposite directions. It's to the left down below, it's to the right up above. With opposite directions, I would expect for charges one thing, but the opposite is what I get for currents. Opposites actually repel each other for currents, and indeed the force here on C is upwards, which would represent a repulsive force. As to the magnitude, we certainly would expect this force to be less than FA because it's further away. So let's finish our computation. We just got the direction as in the upward direction, the plus j hat direction. Now what I have to do is substitute in for my magnetic field, but in this case the magnetic field comes from current I1, so there'll be mu naught I1 on top over 2 pi. But remember now, for wire C, we are at a different distance. We are at a distance R2 from the wire. So the factors that come in then are going to be mu naught I1, because that is what contributes to the magnetic field B. There's my factor of I2. The magnetic field then on the bottom has 2 pi times R, but we are now talking about the distance R2, which determines our magnetic field. Finally, there's the factor of the length, and our direction is in the plus j hat direction. So indeed, we see that the force from C is actually in the exact opposite direction from the force from A. The magnitudes look very similar, except F of C is divided by the larger distance R2, so this upward force is actually going to be less in magnitude than the downward force here.